Hello and welcome to this lecture. In the previous lecture we started talking about the generators and talking about how the overhead that was caused by the iterators, like implementing the iter and a next method and making a record of these successive states, and basically the implementation of a class was overhead in the case of a iterator, but that was automatically done in the case of a generator by the parser itself. So we make use of this yield in order to track every successive call, and the stop iteration exception was handled automatically in the case of generator. So in this lecture we are going to talk about Python generators with the loop. So you could see in this example all of these things, like creating a iterator object and basically going through these iterables was basically happening in the background. So normally generator function are implemented with the loop having a suitable terminating condition. So let's take an example of generator that basically reverses our string in order to see how this for loop is implemented in generator internally. So let me just clear this one and let me define another function that would be reverse str, which is for the string, and let me just pass my str, which is string, to be reversed over here. So first of all I want to just get the length of my string. So in order to get length I have to make use of this len method, and I'll just say len, that is of my str. Now it's time to make a use of this loop. So I'll just say in this range, so range basically create a list from start to stop, and this stop is your exclusive position. So let me say that is length -1. And first of all, after doing this, let me just go back down from this -1, so -1 again. So what we did here was basically creating a list from the highest position, or basically from the last digit of our my string to the first character of our my string. So -1 is exclusive position. That means you will just make a list that goes basically from the length, which is the top length. If the length of this string, let me say if the length of this string is 10, that means you go from 9, which is your last digit, which basically in the case of the string or in the case of the list the index start from 0. That means we have to do length -1 in order to get the last digit, and it should go till 0. That means the first digit, because we have exclusive position here -1, that means we make use of 0, and basically we make use of this backward step in order to create element like 9, 8 and 7 and 6, which is basically the unit decrement in backward position. So after using this, what you need to do is make use of this yield here. So we'll just say yield my str, which is based on this I, which is basically our digit. So let's now call this reverse string. So in order to call the reverse string, what you need to do is I'll just say for character in reverse str, which is our function reverse str, and I'll just pass here hello, and hello should be reversed over here, and let me just say print me character over here. So if I save this one and run this down, then you could see OLLEH, which is the reverse of this hello. And in this example we have made use of this res function to get the index of the reverse order using this for loop. It turns out that this generator function not only work with the string but also with some kind of iterators like tuple. It can be also work with this list. So internally we have the utilization of this I value, which is basically the iterators within this iterable, which is in this case the string. So you can just pass a list or a tuple, which is iterable over here in the case where you can just reverse the digit of the list or reverse the element of your tuple or the list. So this is the implementation where we made use of these generators with this loop. So basically we have this loop internally implemented in the case of generators. So let's see now generator expression. So Python generator expressions can be easily created on the fly using the generator expression. Now it's time to see Python generator expression. So simple generators can be easily created using the generator expression. So it makes really easy for the building the generators. So same as the lambda function that we studied previously, that is to create the anonymous function, generator expression is also creating the anonymous generator function. So same as the lambda function to create the anonymous function, and Python generator expression is used to create the anonymous generator function. So let's see the syntax for our generator expression. The syntax for the generator expression is similar to that of list comprehension that we studied in the previous lecture, but the square bracket are replaced using this round parenthesis. So in the case of the list comprehension, we made use of this square bracket. Now it is just changed to this parenthesis, and basically it is same as doing the list comprehension, and it is used to create our anonymous generator function. So the major difference between a list comprehension and a generator expression is that while list comprehension produce an entire list, so we have to recall that in the list comprehension we have to just provide the expression, you have to provide your loop, and you have to provide the condition, and based on that we just return the list, which is our result list over here in this list, which is our result list. But in the case of this generator expression, it will only provide us one item at a time. So that is the reason, which is basically it provides or produces one item at a time. That is the reason for which the generator expression is much more memory efficient than our equivalent list comprehension. So let's take an example of our generator expression and how it can be created. So let me take a quick difference in this list comprehension and this generator expression. So first of all, let me just create this list, which would be 1 3 6 and let me say 9 would be our list. And now let me just give the list comprehension. That means if you just say result and I'll just say list, so you know how to create the list comprehension. We have already studied before. That is to first give the expression. Let me say x is double, so it is for the power. So I'll just give the loop now. So for x in my list, so it is going to loop around this list element and it will just give the power of each of these digits. That means our output would be 2 6 and it should be 2, it should be 9 and it should be 36, and 9 power 2 is 81. So now we can do same thing for the case of a generator expression. So let me just show here, that is x powered by 2 for x in my list. So if you see here, only the difference is our this parenthesis, which is a round parenthesis instead of this square bracket. So that is only the difference between this generator expression and our list comprehension. So you have square bracket in the case of list comprehension, but a round parenthesis in the case of your generator expression. So let's go over and create the generator expression, and how can we create the generator expression and see the result immediately. So let's see that first. So first of all, let me just clear this one, and let me first, okay, we want to make use of this generator expression. So let me just keep this one and remove that list comprehension. So first of all, I'll just say return me, that is the value a here from this generator expression. So first of all, it will just create this iterator. So what you need to do is we'll just make use of this next method in order to loop around this iterator object. So this basically generator expression returns us a iterator object from which we can make use of this next method in order to iterate, which is basically this over here. So what we did here was basically we created a list which contains something like 1, and basically it contains something like 9 and 36, and power of 9 is 81. So this element is based on this iterator object. So the generation of these elements are based on this generator expression, and after this is caught by this iterator object, we can make use of this next method in order to iterate through these iterables. So now next is we'll just say, let me just save this first and show you the output. Then it is saying 1. Let me just clear this one and let me just press F5 again. Then it is saying 1, which is obviously this 1 over here, and let me just go down and print one more time. So let me just copy this one, it is same. So let me just paste it over here. Let me save this one again and press F5. Then you could see 1 and 9, which is the square of these 3. Let me just paste it one more time. Then you could see, save this one, and you could see 1 9 36. Let me save one more time or paste it one more time, and you could see 1 3 6 9 and our next element, and basically it was 31. So if I just print the next a, which is basically out of this bound, so we'll just save this one and see if it can throw us a exception, that is stop iteration exception. So this was the way in order to create the generator expression, which is quite similar to that of list comprehension. Just make sure you just put this parenthesis in the case where we have put the square bracket in the case of the list comprehension. So just remember, the major difference between a list comprehensions and the generator expression is that while the list comprehension produces the entire list, as we have seen already in the previous lecture, generator expression produces one item at a time. You can see over here using this next method. So this lazy operation of a generator makes more memory efficient than that is equivalent to this list comprehension. So this will be the wrap for this lecture. See you in the next one.